problem that I'm doing states that I have a 0.22 ampere current which is charging a capacitor with circular plates 9.9 centimeters in radius. The plates are parallel to one another and separated by 4 millimeters. The question that we'll be solving asks what is the time rate of increase of electric field between the plates as the capacitor is being charged by this current. I drew a very sketchy model of what this parallel plate capacitor sort of looks like from a side view. I realized that the general expression for electric field, a uniform electric field, is going to be equal to the voltage difference across the electric field divided by the distance between the 2 points where you have that voltage difference. Since this specific uniform electric field is in between the plates of a capacitor, I re-express that in terms of capacitance and charge on each of the plates, which will be voltage between the 2 plates is the charge on each plate divided by the capacitor's capacitance. For an air-filled parallel plate capacitor, it will be equal to the permittivity of free space times the area of each plate divided by the separation between the plates. I then put that in and I get an expression for the electric field between the plates of this parallel plate capacitor. I guess more concisely put, this is an expression for my uniform field that exists between the plates of the parallel capacitor in terms of the charge on each plate. Since the capacitor plates are in the process of being charged, I can say that the electric field is being charged, and it's being charged at a rate which is essentially going to be equal to the rate at which the plates are being charged, times 1 over epsilon 0 A. I then put in the specific value of radius for those plates, from which I can solve the area of each plate in terms of square meters. I then put the expression in for the permittivity constant of a vacuum. I then can put in also the specific current that is flowing on to each of those plates. Of course, there's no current flowing between the plates because there is no conductor. It's just free space, which is an insulator. I then can put all these values in, and from that calculate the rate at which the electric field between the plates is changing. It will be the current of 0.22 coulombs per second, which is another way of expressing the ampere. The permittivity of free space, which is 8.55 times 10 to the minus 12 coulombs squared per Newton meter squared, times the area of 0.0308 meters squared. I then cancel out all the units that are common to numerator and denominator, and as a result I come up with an electric field of 8.07 times 10 to the 11th Newton per Coulomb second. I re-express that in terms of the units that I'm asked to give the answer, and in doing so it'll be 8.07 times 10 to the 11th volt per meter squared.